This is a tutorial about ventilation diagrams and setting up drawings for calculations such as heat loads and ventilation. What you see in front of you is what we normally start with. It's an architectural drawing, and it'll typically have a scale, hopefully a linear scale like this one, and it'll also have a north point, which we should always flag or identify. With those sorts of things in mind, we'll often find dimensions if you can't find a scale, and that will help you, I guess, get the correct scale for the project. As we look closer at the project too, we notice there's an internal core area. This is where there are spaces that require ventilation, there's lifts. In other words, a lot of these spaces will not require any air conditioning. Around the outside is glazing. And you should have enough of a Google Earth or view of the building that you know exactly what's going on. We require that this is marked up in a particular fashion so that other people will know what you're looking at, and so that it will all be done in the same way no matter where we go. This is a ventilation diagram on the drawing that you've just seen. Let me take you through some pertinent features. Firstly, we've flagged or identified the north point. Secondly, we've known and checked that there is a scale. And thirdly, we've marked up colours such that we know where the various zones are. For example, all of the pink, we always use pink or red to denote the outside of the building. This means that there is solar load on this part of the building. If this edge of the building was hard up against another building, then it would not have pink because there would be no solar load. The internal zone is green, and that means that there's no heat flow across this zone. There's still a zone, but it'll be air conditioned here and air conditioned there, and therefore no zoning heat is taken in this fashion. Now, as you can see, these have got some unusual corners. This is a complicated building. This idea of drawing a diagonal out is common. So 4 meters off the glass, we have the edge of the zone, and 4 meters off this glass, we have the edge of the next zone. But how you handle these little nooks and crannies will be slightly different on each project. I suggest to you that it doesn't really matter as long as the center zone, which is the zone in the middle, is not really close to the glass. So whether this is south or whether this is east probably doesn't make too much difference. The other thing you'll notice is that in the core we've used yellow. So yellow draws attention to the heat loads, that there is heat loss or gain across this boundary, but it's usually of a temperature difference type, not as a result of a solar load. So what we would often actually do here is put down a heat load assumption. So I'm going to suggest here that the heat load is proportional, so P, and a factor of 0.5, meaning that the temperature in here is half of the way between the air conditioning temperature and the outside air temperature. If it's 30 degrees outside, 30 degrees outside, 20 degrees inside, then the temperature difference across that concrete will be 25 to 25 degrees at a rate of 0.5. So this allows anybody to check your heat load calculations. As you zoom closer too, you'll notice that we've marked up some red spots. So this is basically the ventilation diagrams that we spoke about before. And you can see here, if the resolution allows, we've got a tea room, female toilet, male toilet, and a disabled toilet out there. And we've actually identified what each of these services are. If you look at the text there, there's an electrical room, so that needs ventilation as well. Male and female toilets. And then over here we have tea room ventilation. So we should see from here all of the calculations in the file stemming from this ventilation diagram. There are also some other notes that allow somebody to check the perimeter zones, 4 meters off the glazing, center zone, everywhere else. We then mark up what the names of each of these zones are. And this is the north zone, and its area is 100 square meters. This is the east zone, and its area is 140 square meters. Over here we have the centre zone, 680 square metres at the southern zone, and the western zone. And I have forgotten to tie the western zone with a marker to where it actually is. So now we all know where all the zones are and what all those areas are. There's also some extra notes here. Tenant exhaust from a client brief somewhere at 0.35 litres per second per square metre. Tenant outside air supply. So this is also from the brief at that rate, 0.2 litres per second. So these are specific services that are provided to the tenant. Note that we've identified they come from the brief, right? You don't just supply them for the sake of it. You need to find that they're identified in the brief. Down the bottom then, I've just made a general note. All zones that are air conditioned are ventilated by the air conditioning at a rate of 7.5 litres per second per person. So now everybody knows what is happening with respect to supplying fresh air to the space.